So here's what we're up to. So I made you skip over this part earlier when I was talking about comments and new lines. We kind of already talked about comments because we encountered that pound symbol in there when we tried to say thing equals 10. Oops, sorry, we didn't try and say thing equals. There we go. So we encountered that when we used that pound symbol, something weird happened where it gave us a dot, dot, dot. Now the dot, dot, dot is Python's way of saying, and what else do you want to tell me? You haven't finished your sentence. So then on the new line, we could say something like, okay, maybe we want to say hi. We're just going to make a string called hi. So what happened on the first part of this was we used a comment. So that's what that pound symbol is again, just as a refresher. So we use that a lot when we're writing files, and we don't want code to be executed, but we want to leave some information so that when I write something really confusing and Albert needs to try and understand it, I can leave him a message and I can say, hey, Albert, here's what my code is doing in plain English instead of him having to read through all the code and be confused. So what we're going to do is actually go back to part 3, part of that, and we're actually going to start using comments and new lines, using a file. We're going to do some cool new stuff. So in this part, I'm going to zoom out a little bit. Oops, not that way. Zoom out. There we go. Okay. All right. So why is this so hard to see? Okay, sorry here, I'm just getting everything in this window working in. Okay, so right here on the very beginning of part 3, where it says comments and new lines, this is an example of how we would use comments and new lines. You can see some \n's and some pound symbols and kind of how we're doing that. Now we're actually going to copy this entire thing from the top here where it says the pound sign all the way down to the bottom down here, and we're going to copy that in our clipboards. And we're going to paste this into a file. So we could go ahead and copy this and paste it right into the Python interpreter, and we could try and run it all there. And it would potentially run part there, or maybe it'll break. But what we want to do instead, actually, is we want to create a new file, and we want to run it in a file. So we want to save it in a file the same way we might save some other type of file. And then we want to use Python to run it. So the way we're going to do this depends on our operating system. So if you're on some sort of Windows machine, you might go in and you might open up the Sublime Text program. I'm going to try and do something that should be doable for everybody. So I'm going to open up Sublime Text. You should be able to do the same thing if you installed it on Windows. If you don't have Sublime Text, you can use Notepad on Windows. You can use Notepad++ on Windows. You can use TextEdit on, I think, Mac. If you're on a Linux machine, you could probably use something called gedit. If you can't find a program that you think will work, raise your hand. One of the TAs will come get you. But now I'm going to go ahead and actually, let's ignore this stuff on the right here because that's for later. Now I'm going to paste everything in. This is not really visible here. Give me 1 second while I fix this. I want to make this actually, silly UI here is not letting me drag this down. Okay, we'll try one more time here. Sorry about the confusing stuff here. Trying to get this to, there we go. Okay. Now we're back. Let's get rid of this. All right, so now I have Sublime Text, gedit, TextEdit, something open that I can paste code in. I'm going to go ahead and paste that code I copied into this file. Now in Windows, however you're doing it, you're going to go ahead and save the file. Maybe it's Control-S, Command-S, or just File Save or something like that. Now I'm going to save this. I'm going to try and put this on my desktop because that's usually the easiest place for me to find stuff. So I'm going to go ahead and click into the desktop, and I'm just going to save this file. I'm going to call this file mayors.py, and I'm going to make sure I save this with a .py. Now, if you're on Windows, there might be a little drop-down where it says extensions, extension types or something. Make sure that you are not saving this as a TXT file or something, but there's, I think, going to be an option in the drop-down that's like all files types. And let's actually try this in Windows as well. So I'm going to paste this in. I'm going to save this. And in Windows, I'm going to click on Desktop. And before I hit save, I'm going to rename this mayors.py. And I'm going to make sure that this all files is selected. I'm not going to click on any of these other things. I'm going to make sure it's all files. Sure. Yes. Sorry. Okay, so we'll start Windows first. So Windows, we open up that Sublime Text program or another text edit program. That's not a Word or something else, so clarify that. And then we paste this code in. And once we've pasted the code in, we're going to save it, rename it something like mayors.py. Actually, name it mayors.py because I'll use that. But we're going to make sure that we're saving it on the desktop. So your desktop probably looks something different, doesn't have tax returns that you need to file. And then once you do that, depending on the program you're using, the text syntax might change, but just make sure that you're saving it with a .py extension, and on Windows it has the all files types with the star or the asterisk in it. And the same thing if you're in some other type of machine that you're saving it as a PY, and if there's an option to select all file types that you're saving it like that. So then we're saving it. If we're in Sublime, it's going to give us pretty colors because it wants to tell us kind of how the syntax works. So this becomes pretty cool because when we're typing things, we can actually see, okay, well, strings in this thing are yellow. And whenever we have a new line, it's going to be that purple. If there's any colorblind people here, there's probably colorblind options for this. Sorry if I don't have any loaded up right now, but we can try and find something later on. So now that we've saved this file to our desktop, we're going to try and actually run the file with Python. Now remember how I was saying that when we see these triple brackets, or so when we see these triple alligator brackets, we're talking to Python. So we don't want to see this actually when we're trying to run the file. Now if I try to do something like mayors.py, or sorry, mayors.py inside of Python, it's not going to know what I'm trying to do. If I try and run the Python command and try and run it on mayors.py, it's also not going to know what I want to do. I'm talking a different language to Python. So we need to get out of the Python interpreter, and we need to be in either a command prompt or a terminal or some other program like that. And the way we can check if this is going to work is if we are in command prompt and we use the exit function and hit enter, it should turn into something else. It might not look like this, and actually it probably won't. For the Windows people, it'll look something like this, where instead of FM core, it might say your name or your username. And from here is where we're actually going to need to interact with the operating system to find that particular file. So on my machine, I'm going to navigate to the desktop. The way I would do that on a Mac or a Linux machine would be to use the CD command. Now we're talking a completely different language. This is not Python. This is, in this particular case, Bash, which is talking to my system. For the Windows people, you're using some other thing, which the CD command, I believe, is also still supported. So you should be able to CD and then type in desktop. For Windows, it might need to be longer. You might need to, I think, just try Windows try this on your desktop and we'll see. So CD desktop. For Unix and Mac, it should work. If you get stuck or something errors out, then let me know. On Windows, I'm going to try it myself. CD desktop, and it should work like that. Now it should look exactly like that. You might, or not exactly like that. The FM core, for example, might be different. On your Mac or your other machines, there might be some other stuff towards the front, but you should see desktop appear somewhere on the left side of that screen. Now once we've done that, I'm still assuming that you have saved the mayors.py file on your desktop. If that's not the case, you might have a problem. You might need to move it back over there. So the way we could check, depending on what question, yes. Yes, I'll make it bigger. Thank you. Thank you. Appreciate that. I thought I could, but does anybody know how to make command prompts bigger? Oh my gosh. Is it properties or edit? Okay, thank you. Ah, perfect. Thank you very much. Let's try 28. All right, is that a little, sorry. Okay, let's try that. Sorry about that, thank you. Okay, so it should look something like that. Now, we're gonna check if we have mayors.py on our desktop. Now, for all of you, this might look quite a bit different after we run this next command, because what it's gonna do is tell us what's on our desktop. It's gonna list out all the files that are there. If you're on Windows, the command is gonna be different from if you're on Mac or Linux machine. So we'll do Windows first right now. I'm gonna type in dir. Now, dir stands for directory, and it's gonna list everything out in the directory. So your response should look something like this. Something like that. Now this is all crap that's on my desktop, things I'm working on, files that are on my desktop. Now in a Unix machine, so a Linux or a Mac machine, when we're using bash commands, we're going to write ls, which stands for list. So list or dir, depending on which machine you're on. When you're done with that, you should see mayors.py somewhere. Now I see it right here, so I'm good, and I see it right here, so I'm good. Is anybody not seeing mayors.py or not able to get to this step? This is one of the most confusing parts of the workshop, I'd say. So if you are confused right now, that is totally fine. Please just let us know so we can help. Is anybody stuck? Yes. So where, say it again. Oh, the content from the file. Sorry if that was also not clear. So in the, I must have closed it out. In the browser that we were loading the content for this particular course in. So if you went to the redmondpython.com/May syllabus, let me find it again.
So you're setting the project now?
No, we're just doing part of it. I'm not starting. We need to do this to make sure the project will work.
We are ahead of the schedule, right?
Yeah, I think we're going back to that in a second. We had to do this first to make sure that fine for the project. I rearranged a few things. Okay, so back on this syllabus. So again, the URL that you need is redmondpython.com/May-5-syllabus. And the content you need to copy and paste into that mayors.py file if you haven't already is located under section 3, or sorry, part 3. So you can find that part 3, and you want to copy everything from here through here. So everything I've highlighted there is what you want to copy and save in that mayors.py file. If you haven't done that, go ahead and open up mayors.py file again and paste it back in there and resave it. Is anybody stuck or needs help? Okay. I'll assume you're okay for now. If you are stuck, we'll go back. We'll help a little bit more. So now what we're going to do is we're going to run the file using Python, except we're not going to be pasting it into the Python interpreter. We're going to be just using Python to run it. So in this case, I'm going to use Python. Depending on how you set up Python in your machine, you might be typing in Python, or you might be typing in Python 3. You can try both of these. But then you'll do Python mayors.py, and then you'll hit enter. So when you do that, you should see something like this. So if I go back to here and I do Python 3 mayors.py, so I didn't set it up right on Windows. So this is an error I'd get. If you get this error, that's fine. That means we just need to fix something. You might also try this, because potentially you set Python, you told your operating system basically, okay, when I type in Python without the 3, I really mean Python 3. Or when I type in Python 3 with the 3, I really mean Python 3. So try both of those, and it should output something like what you see here. Who's stuck? I'm sure plenty of people are stuck. Cool. Are you front rows all good? Is it all working? You need help? You want help? We'll work through this. We're just going to try this once, and this is going to just run right there. So we'll have to fix this later. We'll look at that a little later on, but yeah, that's exactly what you would have done if the path was fixed. So that was right. Okay, so there's probably a lot of folks who have potential issues with this, so definitely if anything's going wrong, please raise your hand and pull one of us in. We may also revisit parts of this towards the end because we want to be sure to get through as much material as we can. So anybody who hasn't been helped, raise your hand really quick if you weren't able to do it before. Yeah. I think we have, so this is going to be a longer one, but we'll have a longer break after this. So. All right. So we are going to, we're going to loop back around. If you haven't had a chance to do this, don't worry. We have 2 hours at the end that we will focus on some more project-related stuff that really will need you to do this. So there'll be a lot of time to kind of work on this particular issue. We're going to change gears back to some more concepts right now so that we can get through those before the end and we can work on a final project that makes that we need them for. So I'm going to go ahead and go down here and we're going to get started on flow control, which is down here underneath part 4. So go ahead, if you're following along with the tutorial, you can go there. And make sure that you are back inside of Python. So you have those triple alligator brackets for yourself again, because we're going to need to start working with Python one more time. So get back in there and make sure you see that stuff like that. So let me go ahead and fix my window here so this isn't so cluttered. This is so hard to do without a mouse. Oh my God, is that what this is? Oh my gosh, that's been there the whole time. What is this doing? God, stop. Okay. All right. So we're starting up on flow control. Great question. We'll answer that. We'll answer that now. So sorry, I know I'm going to cut everybody off. I promise that we will look more at how we can run those files towards the end because the project at the end will rely on doing that. So again, I promise we'll revisit that at the end. There'll be 2 whole hours where we'll tackle these issues. Sorry if you couldn't get to it right now. I just wanted to try and get as many people through that as we could. Promise we'll get back to it. So get back into the Python terminal if you haven't, or the Python interpreter if you haven't had a chance to already. Make sure you have those triple alligator brackets and maybe type something in just to make sure that we're still in Python like this, print hi, and make sure this gives us hi back just to make sure we're in the right place. So what we're going to do next is we're going to look at some options to deal with flow control in Python. So now that we know how to tell whether or not something is true or false, we're going to be able to do some cooler stuff relating to executing different bits of code depending on whether or not something is true or false. So the first way we're going to do that is we're going to use something called if. So we're going to use an if statement that when we say if and we add something towards the end that will get evaluated as true or false and put a colon, then on the next line we're going to indent it and we're going to say, okay, only do this if that thing was true. So let's try this out now. So I'm going to go ahead and say if 6 is greater than 5, which it is, right? So we're going to put a colon there, and then I'm going to hit enter. Now Python isn't doing the normal thing we're used to where it just skips ahead and does, it executes that line because we have a colon here and we have an if on the front. So what this is saying is essentially, okay, we still want to finish this. I haven't finished my sentence to you, Python. I still need to keep going. So that's why it's giving us the dot, 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 because Python is saying, okay, continue, I'm waiting. So we're going to go ahead and actually use indentation now to determine what we do on the next line. So one quick note about indentation. When you're interacting with Python, you can use tabs and you can use spaces to do indentation, but sometimes when you're using tabs and spaces and they get mixed in between, that can get super confusing. So this is going to be a little annoying, but while we're using the Python interpreter, for every line of indentation we're doing, I'm going to make you use 4 spaces by pressing the space bar 4 times. I know it's annoying. In Sublime Text, for example, one thing we asked you to do is when you had a new file that was a Python file, so let me go back in here, and you press tab, what Sublime Text was supposed to do for you was actually turn that tab into 4 spaces. So you can see here, that's what's happening. We don't get the same luxury in the Python interpreter, but I want you to get in the habit of using spaces consistently, just because those are a little bit less prone to breaking things in Python. Question over there, I think, maybe. No, stretching, never mind. Back to it then.
What's the reason for 4 spaces?
So the reason for 4 spaces is convention, partially. 4 spaces are also usually equivalent visually to a tab, but because tabs can actually be visually equivalent to 2 spaces or 3 spaces or 6 spaces, the reason is because we want to just kind of be consistent. So what we asked you to do in Sublime Text was to set tabs equal to spaces and tabs actually equal to 4 spaces. You don't have to use 4 spaces technically, but I'm going to get you in the habit of doing that so that we don't break anything. Question again.
So I can press tab.
Why do you have to press spaces? You can press tab. You're right. I'm going to get you in. I know. I'm asking you to do something really annoying because pressing space 4 times is annoying. I think it's annoying too, and I don't want to do it either. Now, you can press the tab key on your keyboard when you're in Sublime, because Sublime is going to transfer the tab into 4 spaces. Now, when I do this on the Python interpreter, if I press tab, that's 1 single tab character. So that can get confusing if you're using tab and it maybe visually it's represented by 6 spaces worth of width. Spaces, this is a whole argument in Python. Yes, potentially, unless you mix them between and it gets a little wonky. So I know, I admit it, I'm asking you to do something annoying. That's why we write code normally in Sublime instead of Python, but we want to see what's happening live. So question again.
Clarification, are you saying that even though the amount of space between 1 tab and 6 spaces are equal, they're not equivalent, they're not equal when Python reads that space?
So indentation, so Python uses indentation to determine what's going to happen underneath different bits of flow control.
That.
Yes. So yes, I could use a tab character. So if I'm doing this,
let me clarify my question. I cannot switch between a tab and the same amount of space.
Yes, that's a great question. So I could say, let's go ahead and use a tab. Let's say if 6 is greater than 5, print, and I'm using a tab on this first line. So let's give a good example here of why we want to be consistent. I'm not trying to say never use tab. I probably would say that, but that's convention. I could say print, this is a tab line, or whatever. And then I'm going to hit enter again. Python's like, okay, you haven't told me it's done because you haven't finished the indentation, because it still says, okay, maybe you want to tell me another line of stuff. So I could say space, 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 space. It looks the same, right? So I could say print again. This line is spaces. And okay, this line is, let's do SPC, something. And let's S. So it's still, you can still visually see the same. So now I hit enter one more time. What? It doesn't even let us write another line. That's because it's already confused. It doesn't understand. We're using tab on the first, that's tab, that's 4 spaces. It's just, it doesn't know what to do. So the biggest thing is consistency. I'll give you that for sure.
I got it. That's exactly what
the main thing is consistency. The reasons for tabs and spaces we can go into in the last 2 hours, but consistency is the biggest part. So I'm going to be using 4 spaces. If you really want to use tabs, I won't stop you, but if it breaks, I'll blame it on you instead of me. So here we go. We're going to start back at the top, part 4, flow control. Let's get into it. So I'm going to clear this one more time. So I'm going to say if 6 is greater than 5, which is true. Someone said true. Okay, so that's good. So if 6 is greater than 5, let's go ahead and say print 6 is greater than 5. And we'll finish that out. So what happens when I hit enter one more time? So it's still saying, okay, do you want to do another line? And I haven't decided I want to do another line. So what's it going to do now? Somebody in the back row who's quiet. Just guess. It's fine. I don't care if you guess. And what will happen? So after I hit enter, what would happen? Yeah, it will. It will just print 6 is greater than 5. So the reason it's doing this is because we're taking advantage of the results of those Boolean operations that we talked about earlier. So we know 6 is greater than 5. We know that's true. So when we're saying if true, so if we're getting something true, do the thing on the next line. Now, if we change this up and we actually said if 6 is, let's say, equal to 5, because we're using the 2 equal signs to determine equality, and we try to do this again, say print true, question mark? We don't know. Let's try. Well, it didn't do anything. It didn't do it because it wasn't true. So it's actually asking us to put something in there, and if it's true, it's going to do it. If it's not true, it's not going to do it. Does that make sense? Cool. Well, let's look at the next things we can do. So let's scroll down a little bit more. So there's more detail on this that I'm going to skim over to make sure I stay on track for time. So let's go ahead and scroll down a little further. All right. So now let's try some other stuff. So I'm going to start with the in again, if you remember the in. So let's try this again. Let's say if hi in hi there, colon, enter. And let's have this say something back to us. Hello. So what's happening here? Do we remember what happens when we use in? Who remembers? Someone remembers. It finds if it contains it. Yep, that's completely right. So is hi in hi there? Yes, it is. That's true. Exactly. So that's if the if thing we have up here is true. So when we hit enter, in this case, it's saying, hey, do you still want to type anything else? Anything else you want to say? No. So we're going to enter one more time. It's going to say hello. So it does execute that. So we can use anything that we want to evaluate to true or false with that if statement there. So if is saying if whatever Boolean we're giving it, whatever we're evaluating to a Boolean, check if that's true or false, and then do the next thing. Now, if we give it something weird, we could actually do other things to it. Now, we won't necessarily cover too many of those, but let's try something like if 10 colon print hi. What's going to happen?
It is true.
Is it true? Well, let's try. It does work. Why does it work? Well, okay, so Python kind of just gives us this, where sometimes maybe we just kind of want to know if something's there. So so 10 is truthy. It's not true itself. So if we say 10 equals true, that's not actually true. But really what we're doing in if is we're saying, okay, if something is truthy, then go ahead and finish it up. Now, there's certain things that are going to work and certain things that aren't, and you just kind of have to get familiar with those. So one thing we could do is that's another good question right there. So let's say if 0, and I think I had this line up here, print hi. So what happens? We don't know. Let's try it out. Oh, nothing. So we can try this a bunch of different times with different things. And actually what's happening with 0 is kind of commonly associated with being not true. So we're going to give that a kind of a falsy value. It's not equal to false, so 0, well, let's try. So actually it is. I'm lying. I'm a liar. So if we look at type of 0 is kind of special. I lied. So 0 is an int. But when we're evaluating equality, 0 is kind of also equal to false, because when we're dealing with Booleans and true and false, we're kind of also thinking of those as 0s and 1s. Now we can also try this with 1.
So for any other integer except 0, that should work.
Yes. Yes.
Try minus value.
Try it. Let's try if negative 10, right? And then print hi. Works. So 0 is kind of a weirdo because 0 is a
Boolean, and that because of the
yeah. It's kind of says all right. Let's make it falsy because it is and it's also it's equal to if we do double equal to false, it's false. It's kind of some weird things that'll happen in there that you have to play around with just to go like, oh, why is that happening? Oh, okay. Well, Python decided it should do that. So yeah. Albert, do you want to throw any pointers in here? I know this gets confusing and you have more experience than me. So.
Well, This will probably go over, but in Python 3, Boolean is a subclass of integer.
There we go.
So, but it only contains the two values, 0 and 1, and 0 is false and 1 is true.
There we go. So there's some implementation details. So that might be kind of confusing because we don't really know what classes are or subclasses. But basically, behind the scenes, Python is dealing with zeros and ones a little bit more differently than it is with other numbers. So that's my very generic explanation that we won't go into too much detail right now. Okay, so let's keep on going. Now we already kind of talked about some other things, but let's try one other thing we can add to the if. So let's say we want to do something if something is true. Otherwise, we want to do something else. So we can do this. We can accomplish this with if. Let's say if 1 equals 1. Well, actually, let's say if 1 equals 0. So this should be false, hopefully. Let's say print. I'm cheating. I'm using tab because everybody wanted me to. So print high. But let's say I don't want to just stop there. I want to have this kind of evaluation keep going. So let's say if 0 is not equal to 1. I want to do something else. So I want to say else colon, and then I can hit enter again here, and I can write another line. So I can say print, oops. So now when I evaluate this, we're going to go through the whole thing. It's going to first say if this thing is true, okay, do that line underneath that block. And then we say if the else part happens, that essentially, sorry, let me back up. So if this is true, it'll evaluate the stuff under the if section here where this indentation happens. Now on the cases where what we've given is not true, so it's just this one, it'll go to the else part and then execute the code at that same indentation right there. So that's how we're using if and else at the same time. Now we also briefly talked about compound conditionals, but we didn't really mention them by name. So let's look at these in particular. So compound conditionals are and or. And we've been testing those single conditionals, but you can also string them together. So let's say at the simplest case, let's say true or false. This is going to kind of be, well, actually, no, this is a horrible example. We're just going to do this. We're going to do 1 is greater than 0. What is that? True. So that's true. And let's say and 1 is less than 2. True. So both of those things are true. So it's going to give us back true. So what we're really asking when we write this whole line out is we're saying, okay, 1 is greater than 0 and 1 is less than 2. So that whole statement then gets evaluated. If that sentence that I just said is true, then that statement that we've given to Python is then also going to be true. So it's evaluating the whole thing. Now, I could be lying, and I could say 1 is greater than 20, which we know is not true. So I'm going to say in one sentence, 1 is greater than 0 and 1 is greater than 20. Now that is false, because I have just lied in that whole sentence. So Python says, no, you're lying. That's not true. That's just false. So go ahead and try and type these things out and see what you get. And let's see what happens when we're using trues and falses.
What's the difference between false and none, 0 or none?
You're going to try and give you a better answer. You could use, I guess the best answer is you could use them in different ways.
Because 0 is not equal to none. False is
Let's
not
try. Yeah, that's a good question. So 0 equals, oops, I'm sorry, I'm typing this on the wrong page. 0 equals 1. 0 equals false. False equals 0. Oh, go ahead.
Yeah. So this is in general related to all computer languages, not only specific to Python. So there's something called null value. Null value is you're telling the computer this is nothing, null, or none in Python. So it's referred to different. It has a different references in different languages. If you are somebody who's using SQL, you're gonna refer it to as null. If you're using a .NET, it's called nothing, and in here it's called none. That is assignment of nothing, basically, of none to a variable or to a value. Now, why 0 is returning false on the Boolean expression? It all goes back from very primitive programming languages when 0 and 1 binary code. 0 is false off, 1 is on. But then any number else became applicable just like 1. And that's how the programming engine, the interpreter of the language is working. So 0 remained like that. And why it's used like that, sometimes you do a program to read binary itself, and when it is 0, it's an off, when it is 1, it's an on. So they kept that functionality in all programming languages.
Yeah, and specifically, Albert gave an answer that explained why in Python, when you entered in a 0, those things got evaluated that way. And that, if we wanted to look at that more later on, we could do that. And that has to do with Python's built-in classes work, I believe. So I don't know as much about that, but that was a good explanation. If you want to know why Python is doing this, we could look more at how things are implemented. So sorry if I can't give you a perfect answer there.
But even I asked, I'm telling you, if 0 or if none, in both cases, the result is for same, right?
If 0 or if none.
No.
Sorry.
You just say if 0, and then you print something.
Okay. Oops, I'm typing everything wrong. Print hi. That doesn't work because, yeah. Yep. Yep, that's good. So both of those things evaluate in the if statement to something falsy. Some of them are closer to false.
When I say 0 equal to none, it's false.
Yes, that is correct. So this gets confusing because it's not all the same value. It's not all the exact same thing. It's the truthiness or the falsiness of something. So we can also do if, let's go back here, if 1, or actually let's do a better example, if 12. Let's go print high. So that works because a number existing is also kind of truthy. Right? And this is kind of a weird concept. Maybe Albert has a better explanation.
Made a simpler explanation is like every value in Python has a truthiness, and like 99% of the time it's true. There's only like a few values that evaluate false. 0, 9, an empty string, an empty list, an empty dictionary. Maybe like 2 others. Almost everything else is true. The value the truthiness is true.
That's a better explanation, I think. So yeah, by default, except for empty stuff, basically empty strings or empty dictionaries or other data types that are empty, then we would say, okay, yeah, something exists, basically, is kind of what we're trying to find there. It's not a perfect analogy there. Mohammed, how much time do I have before?
You still have until 10 minutes. Okay,
perfect. So let's try and get through a little bit more of flow control here. So who had questions about what we just tried with the ands and the ors? Everybody tried everything and it all made sense to them? Okay, you guys are great. We'll just skip on then. If you did have questions, let me know. Okay, so we can also use variables when we, question, there we go. Yes, so let's go ahead and do that one more time. So if we wanted to, what we could do is we could add more portions of that evaluation block. I don't know, I'm trying to find if there's an example particularly here. So here we go, it's down a little bit more. So I'll get to that in just one second. So really quick example, you could also use variables in there and conditionals inside of the if. So on this example, let's go ahead and say temperature is 32. Oops. Temperature is equal to the number 32. And then we could say if temperature is greater than 60 and temperature is something, let's just do this part here and paste this in. Okay, so I'll make this a little wider so it's more visible. Sorry. There we go. Okay, so if temperature is greater than 60, we know it's 32, so it's not, so we know it's false. And temperature is less than 75. So it's in between those two, basically, is kind of what we're asking when we evaluate this. We'll say, oh, it's so nice and cozy in here. Oh, wait, did I mess this copy up? I think I did. How did I miss? Huh, weird. Let's copy this whole thing. Sorry, I somehow messed up that copy. Let's copy this again. So we said temperature equals 32, and then we have an if-else here. We can still use that variable in there. So it's too extreme for me. So it's either too hot or too cold for us. That's kind of what we're doing in this if-else. Does it make sense how this is working? How we're using variables in there too? And the compound conditionals? Great. We can revisit that later on if you have questions. So now let's add a little more complexity in here. So let's add a little bit of a more complicated loop. So let's clear this screen out. And let's take a look at this. So we set two variables in the very top here. We have sister's age and brother's age. The sister is 15, the brother is 12. So if sister age is greater than brother age, but sister is older. ELIF, so ELIF is a new part that we're learning here. So ELIF is standing for else if. So if this one thing is true, do this. ELIF is so else if this other thing is true. You might see other languages that have else if instead of ELIF, but in Python you can have ELIF. So ELIF sister's age is equal to brother's age, print sister and brother are the same age, else print brother is older. Let me actually make this wider because this is confusing with the overflow there. So yeah, there was no line in between there. That was just word wrap happening. So what happens here in this particular case? Somebody new who hasn't answered yet. Just guess. It's fine if you guess. If it's wrong, that's okay. We'll figure it out together. Someone raise your hand and guess. Sister's older. Okay, let's try it. Sister is older. So this is allowing us to go through multiple conditions to check what's happening in each of those conditions, evaluating them, and then doing something if it's what we want to do. So is that?
So is it kind of else if or?
Yeah, it's yes. It's so ELIF stands for else if. Yes. So we're doing if, else if, and then at the very end we're doing okay. If none of this is true, go ahead and run the else.
So can someone write else if?
You can write a bunch of other ELIFs. So you can't. Oh, sorry. So you're asking, can I do else space if? I think that will break. That won't work in Python. That won't work. It will not work in Python.
Pretty much this function will choose whichever one is true.
Yes, it will say it will. Okay, so it will try, and in this particular block, it will try and say the first. I think it's the first true thing that evaluates. So let's rewrite this. Let's test this concept here. So the question was, is it just going to evaluate the first true thing, or will it evaluate every true thing? So let's change this around. Let's say if sister's age is greater than brother's age, sister's older. ELIF sister's age equals brother's age. Print sister and brother are the same age. So let's actually change this. Let's say if how are we going to do this? Let's make two of these true. So let's actually use the exact same thing, except we'll change it from greater than or equal. My brother are the same age, or sister is older. Yes. So let's try this. So we've done the exact same setup. Let me just clear this again, and we'll try this one more time so it's completely fresh. So let me make this longer again. There. So we only did the first one that we got to. That was true. So what this block does is in the if, it says, okay, is this true? Okay, execute the stuff in there, and then we'll move on. We'll skip everything else. So this kind of gets executed as a chunk there. So if, ELIF, else are all chunked together. If the first thing we can encounter that's true, that's what we're going to execute. We're going to skip the next bit. Does that work?
Because it's already true.
Because we already did true, we already executed. So in this particular syntax, we know, all right, we're skipping that. If we wanted to check it twice, we could do if, and we do another if, which would be separate. So if we change this, for example, to be, where did I paste that? It was over here. So if I change this to if, now this is going to be a little weird because Python expects something else. So this is kind of a weird syntax error when I'm typing it in because Python actually expects me in the interpreter to have another enter here so that I can actually distinguish between these different lines. So let's try this one more time. So now what happened here is I pasted that whole thing in, it evaluated the first one, and then we had a new chunk of code, and then it evaluated that second statement together. Does that make sense?
Sure.
Cool. Is that clear? Great. All right, so let's head back over here. So, go ahead. Go ahead. Question. 5 minutes. Okay. We'll get through as much as we can here. So, if you don't need an else block if you don't want it. So we can go back into here and we can actually completely remove this else block, and let's use this same chunk of code. Let's go back in here and let's run it again. It worked fine. We don't need the else. So if we just want to do something if it's true and not do anything else, we don't need to have the else in there. Okay. So that's some basics. Now, let's talk about functions for the next 5 minutes before the break, because we're going to need to know enough about those to actually write one of our own and work with one of our own. So we already been working with functions this whole time. Every time you saw those open close parentheses where we were typing something in after a word, we were actually using functions. We just hadn't written them yet. So when we're using len of hello, this was using the len function. It's taking some input and it's giving us something back out. So when we're working with functions, they're going to allow us to encapsulate little bits of logic. So maybe we want to always be able to check, okay, I just want some new function that I'm defining to check if some string is in some other string. Or maybe I want some new function to add things together and then multiply them by 20 or whatever you want to do with a particular work that you need to do. So we can write functions to encapsulate all that logic for us and then be able to do that given some inputs. So let's take a look at how we can actually do this. So we're going to talk about writing functions and defining functions. And the way we do this is with something called DEF. And we're going to go ahead and use this. So let's clear this one more time so we start over. And let me fix this up so we can see both at the same time. So when I'm doing this, I'm going to write, and let's all write our own functions right now. Let's call DEF, or we'll do DEF here. And then we're going to come up with a function name. In this case, we're going to just come up with a very, very simple one. We're going to come up with an add function. And in this add function, we're going to do DEF add and an open parenthesis. And this is going to start what we expect the function to be given. So we're just going to say something like num1. And then we're going to put a comma, because the comma will differentiate between the first thing we expect it to be given and the second thing we expect it to be given. So then we're going to do num2. Then we're going to finish that. We're going to say, okay, we only expect these two things to be passed into this function when we're using it. Then we're going to put a colon, similar to how we do that with other parts, like the if and the other things we've been working with. And then we're going to hit enter. And now we get the dot, 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 so we can say something else to Python. We can tell it what we actually want it to do, the function itself. So we're going to have to use a tab or those 4 spaces. And then in here, we're actually going to write what we want the code to do when it's given these things. So we want it to actually, let's say we want it to add these up and give it back to us. So this is kind of a very small function. We could do this easily other ways, but maybe we want to just encapsulate this logic. So let's go ahead and say we want to do num1 plus num2. Now I could finish the function definition here, but the problem is this would add the numbers up and it wouldn't give me anything back. Because I actually want this function to give me something back, I need to use another word. So I need to use something called return. Oops, here we go. So return will actually evaluate, it will evaluate everything in there. So it'll evaluate num1 plus num2, and then it's going to return whatever is that stuff on the right. So if we just said, no, maybe we don't even use num1 and num2, we just return 1,000, then the add function is just going to always give us 1,000 back. So that's not exactly what we want to do. So we want to do num1 plus num2, and then we can go ahead and hit enter twice, and we just define our first function. So now let's go ahead and use add, and let's go ahead and use this with 10 and 12. So what'll happen? There we go, it returns 22. Now, okay, well maybe there's something we used that we didn't expect it. We didn't expect this to work. So let's say hello. Let's also say hi. Well, what's actually happening in the function is we're using the plus operator in there. So what we're doing is we're either adding numbers together, or so integers or floats or anything else, or we're concatenating strings. So one thing we have to start to realize when we're writing functions is that they can be used in ways we don't expect. So we can still break things in functions the same way we got errors when we tried to do these things just by typing them in. We can get errors from our functions because maybe they're not checking to make sure that that the number is a number or trying to coerce it. And back to the very early question that you were asking very early on about why we would need to use string. Why don't we just put quotes around it? Well, let's say I wanted to define this function, and maybe I actually just want this function to be something like, I'm going to call it con, and I'm going to make this short for concatenates. And I actually just want this to be my str1 and my str2. And then I want to concatenate them together. So I want to do my str1 plus my str2. But what happens if we give that function integers? It's going to break it because we just saw that earlier. So let's actually try and have some sort of solution there. Let's use str on both of these. So back to what we were doing before, oops, str. Now this would actually solve the issue that you brought up a while back. I'm sorry, I'm not sure of your name. But that would actually fix this. So we're keeping the return because we still want to return what we're getting. So I'm going to go ahead and enter twice. And now if I use this new con function, which is short for concatenate, this is my bad naming convention because con is kind of ambiguous. But let's say I wanted to concatenate 10 and hello. Now normally when I was trying to just do 10 plus hello, this would break. But because we've actually said inside the function, okay, use str, turn whatever it is, let's make sure it's a string, if we can make sure it's a string, and turn that into a string before we run the plus. Yeah, so you write these functions to save yourself time later. So you evaluate, you can put a bunch, you can put ifs and else, ifs and elifs and else's in there. You can have a bunch of logic in there to do different things. Now